is all about similarity. So we've talked a lot in geometry about congruence. What's congruence? If two figures are congruent, what do you know about them? They're the same. They're equal. They're identical. They match up, right? Now we're going to move into more similarity in this chapter. And similar polygons aren't going to be equal anymore. They're going to be similar to each other, right? They're going to have things that are the same, but they're not identical anymore. So this is where ratios really come into play, because a ratio is a comparison of two things, okay? So an example of a ratio. Can someone give me an example of a ratio? What?
2 to 1.
2 to 1, right? 2 to 1 is a ratio. If we said there's a ratio of 2 to 1 boys to girls in the class, that means there's 2 boys for every 1 girl, right? So that's a ratio. So 2 to 1, you could write that like this. You could write that like this. Or you can even write it like that, right? If you wanted to not give it numbers and just think of it as a relationship, you could do the same thing with letters. A to B, or A to B, right? Those are all ratios. It's just comparing the two quantities that we're talking about. But two very important things to do when dealing with ratios, okay? The first is when you are working with ratios, you always, always, always need to reduce, or you could say simplify, okay? A lot of times we write it as a fraction. Just think of it as reducing that fraction, simplifying that fraction every time. We always want to reduce, okay? The other thing when dealing with ratios is you want to use the same units. So if I'm trying to say the comparison of this to this, I want to say like 2 inches to 6 inches, right? I want to compare my units the same, because then when you reduce, it reduces well. If you have inches to feet and then you try to reduce that, it doesn't reduce well. So when working with ratios, we're going to reduce and we're going to use the same units. And here's your first example of what we're going to do with that. So this says a pygmy rattlesnake averages 18 inches. Anyone have a pet snake? No? No snake people in here, huh? My brother had one. They creep me out. Have you ever held a snake and felt it like, oh, I can't. It's too much for me. But some people like it. It's just not mine. Okay, anyway, pygmy rattlesnake averages 18 inches. A western diamondback is 5 feet 6 inches. What is the ratio? Okay, so what is this setup, the ratio of the length of a pygmy to the western diamondback? Okay. One important thing with ratios is you give it in the order they gave it to you. Otherwise, if you're trying to solve something, you might flip-flop those, and then people are confused. Well, which one are you talking about? Is it this to that or that to this, right? So the order they give it to you in is the order you put it in. So a pygmy to a western diamondback. Anyone see something that's going to need to happen in this problem? Nico?
You're going to simplify?
You are going to simplify. Is that what you were going to say?
I'm going to say that you're going to turn the feet into inches.
Feet into inches. Tell me your name again.
Jacob.
What is it? Jacob. Yes. Okay. This is going to take, I'm terrible with names, you guys. I'm really sorry. If you're new to me, I'm going to get there, but it's going to take me a little bit. Okay. So we have 18 inches. We have 5 feet, 6 inches. It would be easiest right now to convert everything to inches. Okay. You could do feet. What's 18 inches in feet? 1 foot 6 inches, which would be 1.5 feet, right? So you could call it 1.5 feet to 5.5 feet, but you can't leave a ratio with decimals in it. So then you'd have to double everything, and then you could reduce, and it's just ugly. So yes, you could do it that way. I don't recommend it. I would say I know 5 feet is going to be 5 times 12 or 60 inches. So how long is a western diamondback? 66. Don't forget to add those extra 6 inches on, right? So it's 66 inches for the western diamondback. That's this guy. And 18 for the pygmy rattlesnake. Which one goes on top of our fraction?
18.
The rattlesnake, right? So the 18 on top, the 66 on bottom. Is that our ratio of pygmy rattlesnake to western diamondback?
No.
Yes and no. Not fully, right? What do we have to do? Simplify. So if we reduce that, everything's divisible by what? 6. So 3 to 11, okay? You may write that like this. You may write it like this if you like that better. I don't care which one. They're both correct. Pick the one you like. I tend to do the fraction probably most of the time, but you may do whichever one you want. Questions on that? Okay. Let's see how much you remember from last semester. This says the measure of two complementary angles. Those are not angles that say nice things to each other. What are complementary angles? Angles that add up to 90. I love you raising your hand, and I should get better about calling on other people. But I tend to just get in a place of just tell me your answer. So don't feel like you have to raise your hand. I appreciate it. And if you want to raise your hand, that's great. And I may start calling on people like specifically if it's always the same person answering all the questions. But I would love if you just shout out what you know. That's great. So complementary angles, two angles that add up to 90. It says they're in the ratio of 1 to 3. Okay. Now, some of you are the type that you can kind of put that in your head and be like, oh yeah, it's this and this. I'm not that person. Others of you are probably also not that person. But if you can do that sort of thing in your head, that's fine. But I'm going to show you a way that you don't have to do it in your head if you're like me. So if you have a ratio of 1 to 3, and we're trying to figure out what the actual numbers are of the two angles we're talking about, they have a common factor. Right? If they are similar, they have some common factor. We're going to call that common factor x. So whenever you see a ratio like this, turn it into 1x and 3x, okay? Because they have a common factor. So in that setup, if I'm saying it's two angles that are complementary, one of them's 1x and one is 3x, what do I have to do with the 1x and the 3x?
Plus.
Yeah, add them. Yeah, we're going to add them together and set them equal to what? 90. So we get 4x equals 90. We divide that by 4, and x comes out to 22.5. Okay, now the question was not what is the common factor, but what are the measures of the two angles? Can you tell me what one of those angles would be? 22.5. If one is 1x, right, 1 times x is 1 times 22.5. So angle 1 is going to be 22.5 degrees. Okay. What's the second angle?
22.5 times 3.
Right. 3 times 22.5, right? Because that one's 3x and x is 22.5. So you get 67.5 degrees. Can you verify for me that that's the correct two numbers? Why? They add to 90, right? If you add them together and you get 90, you feel pretty good about that, okay? Okay, so sometimes there's what's called an extended ratio, and that just means make the ratio longer. A to B to C, or A to B to C to D. You can have a whole slew of numbers that you're comparing here. So when that happens, it really doesn't change much in how you set the problem up. It says the length of the sides of a triangle are in the extended ratio, 2 to 4 to 5. Now, what did we say we do when we see a ratio?
X.
Put an X with it, right? Add that common factor behind your numbers of your ratio. So if the perimeter of a triangle is 77 inches, what equation can I set up right now?
2 plus 4x equals 4 plus 5x equals 77.
Yeah, take the 3 with their x's, so 2x plus 4x plus 5x is going to equal 77. Now, here's where we pay attention, right? Details matter, especially in math. Details matter. The question is not what is x. The question is what is the length of the longest side of the triangle. So this represents one side of your triangle. This represents another side of your triangle and the third side of your triangle. So once you find x, what are you going to do with it? Plug it into what?
To the biggest one.
The biggest, 5 times that number, right? So let's solve for x first. 2x plus 4x is 6x plus 5x is 11x equals 77. We'll divide by 11. Okay, so we get x is 7, but that's not what they asked us for. They asked us for the longest side. So how long is the longest side of your triangle? 35 inches. And I love that you said inches. Label your stuff, right? 7, I guess I should write it the other way to not confuse. 5 times your x value is 35 inches. So the longest side of that triangle is 35. Now, if you really wanted to check your work, you could plug in 2 times 35 is, 2 times 7 is 14, 4 times 7 is 28, 5 times 7 is 35. If those 3 add up to 77, you've checked your work, right? Questions on that? Okay. Moving right along. Can you tell me what a proportion is? I'm sure you've seen a proportion. I guarantee you've seen a proportion. Anyone think they can give me a description of a proportion? Or think you can fill in that word? An equation that states that 2 ratios are equal, right? It's a ratio, something over something equals something over something, right? So you're saying that these 2 ratios are equal, okay? In a proportion, there are 4 numbers. 2 of them are called the extremes of proportion. So if I have A over B equals C over D, I would say my extremes of proportion are the first one and the last one, okay? The means of proportion, if you think like mean, median, and mode, mean means what? If you find the mean, you find the average, right? The average is in the middle. So the means of proportion are going to be the middle 2 numbers, B and C in this situation. We don't do a ton with that, but if you ever were to see those terms, that's what they're saying. Extremes of proportion, like the extremes, right? You're either far to this side or you're far to that side. You're extreme. And then the means in the middle. Okay, so with proportions, you often solve by cross multiplying. And this is one where I feel like you've done it a lot in your math career, but some of you have been doing it wrong for a while. So you kind of have to break that mold and start doing it the right way, okay? What I usually see done wrong with cross multiplying is people, instead of saying this times this equals this times that, people multiply the A times D and they multiply the B times C, but then they turn it into another ratio. Don't do that, okay? When you cross multiply, you're saying A times D equals B times C, okay? And I'll show you right here what I mean. Actually, you'll show me what I mean. What do you do with letter A here if you're gonna cross multiply? What are you multiplying? Is A times D 6 times 4, right? So that's 24. And then you set it equal to 5x, okay? Again, it is not 24 over 5x, right? That's the mistake that I tend to see. So from here, all you got to do is divide by 5, and your x comes out to 24 divided by 5 is 4.8. By the way, I use color a lot. I like to change colors. If there's ever a color up here that you're like, yep, that one doesn't work for me, just tell me and I'll pick a different one. But I really like color. Okay, this one's a little bit different. Notice there's an expression up here instead of just a number or a variable. What do you do differently when there's an expression? What shows up? Anyone know? Parentheses. Yeah, if there's an expression there, if I'm going to multiply this by that, I have to put parentheses around that expression, okay? So this is going to be 6 times y plus 3 equals 12 times 5 or 60, okay? From here you have options. I think I know what most of you would do. but I'm curious, what would you do first in this problem? Take away the 6? What do you mean by that?
Divide it out.
Divide by 6. Okay, I don't think that's what most people would do. How many of you would divide by 6 right now? What would the rest of you do?
Multiply.
Distribute. Okay. You may do either. I actually love the idea of dividing by 6 because it leaves less room for error. But every year, people want to distribute. So you may do it either way. If you divide by 6, you get y plus 3 equals 10, and then you subtract 3. If you distribute, it's great. I love distributing. I just don't love that people forget to actually distribute to both things. So if you're going to distribute, please distribute to both parts of the expression, okay? 6 times y is 6y. 6 times 3 is 18. That equals 60. Take away the 18, and you get 6y equals 42. And then divide by 6, so y is 7. Okay. And you could just plug it back in if you want to check it. 7 plus 3 is 10 over 12, and 10 over 12 does reduce to 5 over 6. So you know you got it right then. How we holding up? We're almost done. Good with that? Okay, here we go. The last thing is the properties of proportions. There are 3 properties that you're going to use in this lesson and beyond. And they're really so lovely because of these properties, you can actually do a problem wrong and still get the right answer. So you should think the properties of proportions, too bad they're not personified, you can't really thank them, but it makes life just quite lovely oftentimes when you set a problem up wrong and you still get to the right place because these properties allow you to do that. So here's the idea. If we start with a over b equals c over d, one of the properties of proportions says I can take the reciprocal. What's a reciprocal? Flip it, right? Flip it over. So a over b becomes b over a. I can take the reciprocal of both parts and set them equal, and they will still be equal. Okay, so one is flip both parts over. A over b becomes b over a, c over d becomes d over c. Still an equal proportion, okay? The second one is that you can switch your means. So what b and c were, you can swap them, and now it's c and b. In my head, I always think of it more as instead of doing a over b, I go a over c, right? The ones across from each other can become my ratios, but it's really, you're switching your means is why it works. And then the last one is you can actually take your numerator plus your denominator, so a plus b, right, our denominator, and put it over the denominator, and it will still equal the same thing. That one doesn't get used a ton, but it's kind of brilliant that that works. I wouldn't have come up with that on my own, but it sure works every time. So, okay, so here's what you're going to do with this. They're going to say you have this diagram, and in this diagram, x over 10 equals y over 9. Let's write that proportion a different way. So if it's x over 10 equals y over 9, and now they say this, x over y would have to equal what over what? 10 over 9. Which property did they just apply?
Switch the means.
Switch the means, right? This one right here. They just swapped, well, we'll go here. They swapped these two numbers, right? So x over y is 10 over 9. What if instead of x over y, what if I said y over x? What would that equal?
9 over 10.
Y over x would equal 9 over 10. Okay, so it's just taking these ideas and applying them. You could also say we wouldn't do this because it doesn't simplify things at all. But if I wanted to use the third principle from this setup, I could say x plus 10 over 10 would have to equal y plus 9 over 9. Okay, so that's all the properties that you could do. They will all hold true. They will all make equal ratios, an equal proportion, a true proportion. Any questions on that? Okay. Who's excited about this one? Quadratic formula. Remember that one? I'll do a little recap on that tomorrow.